Recording is rolling. It is Wednesday, February 26th. We're continuing solutions from this SAT packet. We left off on number 12. We left off at number 12 yesterday, so start on number 13. Today's final call for simple harmonic motion and waves quiz. Most of you guys turned this in weeks ago, but I have to get this back to you guys. So today's last day and ticket that. And then, I think we're really lucky to be living in Brevard, where we get to see rocket launches all the time. There's a rocket launch tonight at 7:16 p.m. that's going to the moon. So if you want to see a rocket launch to the moon, then check outside after 7 o'clock tonight. All right. So, you guys ready for SAT? All right, we're picking up number 13. Right away, I see a system of equations. I'll write this bigger for the camera. So this is number 13. I got y equals negative 2x. And I got 3x plus y equals 40. So here's your system of equations. Question is, okay, the solution is xy. What is the value of x? Okay. Now, I can think of 3 different ways to solve this. Guys, what's one way to solve it? It starts with an S. Substitution. What's another way to solve it? Starts with an E. Elimination. And you could also use what starts with a G. Graph. Okay. Let's do all 3 of these, just so you can really see like all the available ways to solve this. Okay. So substitution. Could I take this y is negative 2x and very simply substitute it into that y? Right? That would get rid of the y's, and then I could solve for x. So that gives me 3x plus, and then instead of saying y, I'll say negative 2x. Same thing. And that's equal to 40. Oh, and guys, what is this right here? X. There's the answer, 40. The answer is 40. So number 13. There was no multiple choice, so you had to write out the number 40. So if you wrote the number 40 in your box next to number 13, give yourself a check mark. And so that's substitution. Let's try elimination. Now, elimination, can I subtract one equation from the other equation? Okay, let's do that. If I start with y equals negative 2x, and I subtract off the entire next equation, do you guys see what I'm doing? Okay, I have negative 3x. So here's the elimination method. I'll get negative 3x. Then y minus y is 0. That goes away. And then I have negative 2x minus 40. You guys see if I take the top equation, subtract the bottom equation, I get this expression right here. Is that okay? Is it? All right. Now, I could add 2x over, plus 2x, plus 2x. I'm just doing some algebra here. It gives me negative x is negative 40. It's left on the side. Divide both sides by negative 1. X is 40. Hey, look, it's the same thing. And so here's the substitution method. Here's the elimination method. They're both given the same answer. Right, here's it. Okay. And the third way you could solve this is with a graph. So let's do rewrite the equations. Y equals negative 2x. And actually, I'm going to rearrange the second one to make it put it in slope-intercept form. Guys, how can I take this second equation and put it in slope-intercept form? What do I have to do?
Isolate the y.
Yeah, isolate the y. Yeah, and I can do that by subtracting over the 3x. Okay, so that would give me y equals negative 3x, and then I got a plus 40. Okay, is that true? Is that okay? So this is my system again. System, which is 2 different equations. What do these look like graphed? X, Y. Can you guys graph those 2 equations? Everybody definitely has their notes out, right? Everybody's got paper out for notes. Okay. Because guys, sometimes later today, I'm going to be walking around the class, seeing if you guys can draw these graphs. But these are pretty straightforward. I'm pretty sure everybody can graph these. Like, what does y equals negative 2x look like? Like, if you plug in 0 for x, you get 0. If you plug in 1 for x, you get what? Like negative 2. Okay, and then it's a straight line. So isn't that graph right there? Y equals negative 2x. You guys could all do that, right? Okay. Now, if I do negative 3x plus 40, well, I see the y-intercept, which is up here at 40. Here, let's call this 40. Okay. And guys, if it's negative 3x, isn't that a steeper slope that's also negative? Could that possibly be, just kind of ballparking it, maybe kind of like that? Could this be y equals negative 3x plus 40 right there? Is that true? Here, this is y equals negative 2x. Get rid of this. Okay, so I got these two. Do you guys see where these two lines cross? Do you guys see that point right there? Right? Now, see if you guys are following. See if you guys can put this together. Who can tell me what is the x value, the x coordinate, where these two graphs cross? 40. It is 40. How'd you know it was 40? Because that's the way we solved it on this side. X is 40, x is 40. Okay. This is the graphical solution. Wherever the two lines cross, the x coordinate is the answer to x, and the y coordinate is the answer to y. Okay? Which, by the way, if you plug in 40 for x, what does that give you for y? Negative 80, right? You see that? Negative 80. Ah, that also aligns with the graph. Could this reasonably be negative 80 down here? You see that? So this is negative 40, sorry, positive 40, negative 80. You see that? So 40, comma, negative 80. Okay. All right, there you go. There's 3 different ways to solve that. Number 14. Ooh, we got a table of values. So we got data value, 6 through 14, and frequency. There's different numbers. Now, there's not a story attached to this, but this sure does remind me of yesterday. You guys remember yesterday there were a bunch of plant heights? You guys remember that? Okay. Let's just carry that story over to this data table. What if I have a height of 6 centimeters and there are 3 of those plants, and 7 centimeters, there's 3 of those plants, and all the way up to, guys, what would my tallest plant be? 14 centimeters? And actually, there's 6 of those. Do you guys see that? Okay. Now, question, frequency table, we've got 57 data values, so let's call it 57 plants if you like. Okay. What is the maximum data value in the set? Guys, what's the maximum value? 14. Yeah. The answer to number 14 is 14. And you had to write out that number because there's no multiple choice. So you had to write 14 in the box for number 14. That's your tallest plant. Now, earlier today, somebody asked, well, why isn't the answer 11? Somebody thought the answer was 11. No, 11 is the answer to a different question. Who can tell me what question could you ask where the answer would be 11? Yeah, the most frequent. If they say what's the most frequent, or if they say what's the mode, right, that would also be 11. Right? But your guys' question was what's the maximum value? Because the answer is 14, number 14. Right, are we good on 14? Number 15. One leg of a right triangle is 43 millimeters. The hypotenuse is 196 millimeters. What's the other leg? Let's draw this out. 15. Triangle. It's a right triangle, a right angle. Oh, one leg is 43.2 millimeters. The hypotenuse is 196.8 millimeters. And what is the, well, I'll call it side x, solve for x. Can you guys solve for x? Okay. Now, what process? How would you solve for x? Using what? Pythagorean theorem. That's right, Pythagorean theorem. We can say x squared, we're solving for x squared plus 43.2 squared. You guys know it's millimeters equals 196.8. That's millimeters also being squared. Okay, just like that. Is that true? Then if you solve for x, well, 2 steps. I subtract over the 43 squared and then take the what? Square root. So it's going to look like this. Square root of 196.8 squared minus 43.2 squared. Okay. And then this is all some number of millimeters. I can pull the unit up. Just like that. You guys good with that? Good. All right, let's see what happens. I got 196.8 squared minus 43.2 squared. I'm looking at, 192 exactly. Of course, it's millimeters. That should be the answer. That is C. Guys, 15 is C. You guys got 15 is C? Everybody good? Oh, now here's a fun side thought. Guys, the fact that this is an exact value, like this is actually a whole number. Okay? There's no irrational number, something like that. It is actually a whole number. tells you that this is actually a special right triangle. Now, there's a bunch of special right triangles. You guys probably know a handful, like 3, 4, 5 is one example of a special right triangle. This is also a special right triangle. Probably one I've never seen before in my life, but there it is. But you know it's special because it's a whole number here. I have a follow-up question. Now, this question you probably don't need to know for the SAT, but I do want you guys to know for this class before you graduate high school. Who can tell me, what is that angle theta right there? I'll solve it. You guys solve it. Let's see if we get the same thing. All right, I have the answer. All right, who can solve for that angle theta? I drew it down the bottom left corner. You guys go ahead and solve for theta. Who knows? How many degrees is that? Who can solve for that angle? Who knows how to solve for the angle? That's how you extract an angle from a triangle. Yeah, you have to apply some kind of inverse trig. Right? And now you actually have 3 options. Well, because remember at this point, here, this might help you out possibly. You guys know this is equal to 192 millimeters at this point, right? You guys, we got that answer. That's where that comes from. All right, so that could be helpful, maybe. Okay. How about now? Who knows how many degrees is this right here? Ah, yeah, all right, at least got it. It's like 12 point something, 12.7 degrees. Okay. Now, you can get this a few ways. You can do inverse tan. You can do inverse sine or inverse cosine. Yeah, I'll do a couple of them. Okay. Because if you do inverse tan, you have to do what over what? The 2 legs? Yeah, opposite over adjacent. So it'd be 43.2 over 192. Right, millimeters. Okay, let's see. Inverse tan, 43.2 on 192. Yep, that's 12.68 degrees. 12.7 degrees, I'll call it. What if you had done inverse sine instead? And I'm writing inverse sine because it plays off the 2 values that they gave you to start with. Okay. That would be 43.2 over 196.8 millimeter, whatever. Let's see, does that give you the same thing? It should. 43.2 over 196.8. It's exactly the same thing. It is. Look at there. So you guys know how to get an angle from a right triangle. All right, next question. Oh, you're gonna number 16. A wire with length 106 inches is cut into 2 parts. Let's draw this out. 16. I got a wire. I know the full length of the wire is 106 inches. We're going to cut this into 2 parts. I'll call this X and I'll call this Y. And they're saying the value of X is 6 more than 4 times Y. What's the value of X? So there are a bunch of questions in this packet where SAT wants to know, can you take a phrase and turn it into an equation? In fact, since there's 2 values here, an X and a Y, you actually need how many equations to solve it? Guys, can you solve 2 unknowns with 1 equation? No. Can you solve 2 unknowns with 2 equations? Yeah, 2 independent equations to solve 2 unknowns. Right? So let's set up a system of equations right here. Somebody tell me, what is 1 equation? Yeah, X plus Y is 106 inches. And then the second equation we can get out of this phrase, they say the value of X is, so X is, that's like X equals 6 more than 4 times Y. Is that like 6 more than, so 6 plus 4 times Y? Right, is that it right there? The 6 would be inches. Okay. Here's your system right here. Okay, you guys good with that? Now, how do you solve the system? Oh, well, you saw one of these earlier today. You guys got options. You can do substitution, you can do elimination. We gotta get to X though, right? Okay. So how about what do you guys feel like doing? What method? Do I do substitution or elimination? Sure, let's do substitution. Now, if I do substitution, what I could do is I could take this top equation. There's like 10 different ways to solve this. I could rearrange this to get y equals negative x plus 106. Isn't that true? I'll drop the unit eventually. Right. Because then everybody sees where that comes from, right? Just take the top one and rearrange it. Then I can take that expression, I can substitute that into this y right here. Hence, the y will go away, and I can solve for x. Okay. So let's bring this down. Now I got x equals, I got 6 plus and 4 times, but instead of y, I'm going to write out this right here. Negative x plus 106. Is that okay? Are we good? Are we good? If you have any question, let me know. Okay. So x equals, how about I distribute the 4? Should I do that? So 6 plus, I got a negative 4x, and I got a, what's that, 424? Like that? Ooh, guys, can I add 4x over? I got 5x equals, and then combine these two. Is that 430? Is that okay? All right, last step is to do what to both sides? Yeah, divide by 5. Now, guys, dividing by 5 is the same thing as dividing by 10 times 2. And I'm saying that because you could actually do this without a calculator. Because what is 430 divided by 10? 43. What is 43 times 2? 86. That's the answer. 86. So number 16, we do have multiple choice. 16. Yeah, the answer is D, 86. Number 16 is D, 86. If you wrote D, give yourself a check mark. Number 17. Ooh, it's about to be graph time. Everybody definitely has their notes out, right? You guys, you ready to make a graph? I'm about to walk around class in a few minutes. I'm going to see how many of you guys know how to make this graph. F of x is, we got an x plus 6. And that's multiplied by x plus 5. And that's multiplied by x minus 4. I'll set you guys up some axes here. Got x-axis, y-axis. Okay. So guys, all day today, there's only been a few students who have known how to make this graph. Okay. But you guys are a pretty sharp class. So, curious to know how many of you guys know how to make this graph. Let's go ahead, make that graph right there. Here, I'll give you guys a hint. If you don't know what a graph looks like, could you just plug some values in for x and just start plotting some points? And eventually the graph emerges. Like if you graph 100 points, then eventually it's gonna come out, right? Ooh, close, close. Okay. Peyton got it. Yeah. Okay. Peyton got it exactly. Alexander got it. Okay, so got 2 winners so far. Almost. What's upside down? Oh, yeah. Okay, let's do the points. So you got a good start. Okay. Yeah, some of you guys have a good start. Some of you guys got some coordinates you guys can figure out. Elise got it. Yeah. All right. Yeah, Olivia got it. Yeah, so Luciana got it. Yeah. All right. So, all right. Now I had a sharp class. All right, a bunch of you guys are getting this, which is awesome. Okay. So let's go through a method. I see 3 different things multiplied together, and I can do this trick. I can say if any one of these parts is 0, the whole thing would be 0, and I can very quickly find my x-intercepts. Guys, what's one of the x-intercepts? Positive 4, I heard. Positive 4. Positive 4. Because if you plug in 4 right here, this bit goes to 0, and that zeroes out the whole thing. So that's definitely one of your x-intercepts. What's another x-intercept? How about negative 5? And also what? Negative 6. So I can throw negative 5 on the board. I can throw negative 6 on the board. And those are also x-intercepts. Is that true? Okay. While we're at it, let's find a y-intercept. Guys, how do you find your y-intercept? Or maybe I'll say it a little bit different. what is the x value where it crosses the y axis? Yeah, the x value would be 0. So if you plug in 0 there, and also there, and also there, so plug in 0 for x, is that 6 times 5 times -4? Aha! What does that come out to? -120. Okay, so my not exactly to scale, but just to get the idea. Somewhere at 0, -120, it would cross there too, wouldn't it? Isn't that true? Here's another way to think how to put this graph together. Is what if you expanded this whole thing? So you FOIL this and then you distribute that. Now that would take a long time. That would take like 10 minutes. Right? But at the end of that process, your very first term would be x to the power of what? 3. Yeah, do you guys see if you multiply this whole thing out, it's x to the power 3 plus, and then like a whole chain of terms after that, right? Which is a cubic shape. And guys, what does a basic cubic shape look like? This right here. I bet the graph looks pretty much like that. Right, pretty close, do you guys think? Right. All right, so there's f of x right there. There's f of x. Right, everybody's good with f of x? Okay. All right, so we got that. Which table of values represents f of x and then -3? Ooh, guys, f of x and then -3. Is the original graph f of x shifted which way how much? Down 3? Right, down 3? Right. Could that be here, maybe I'll do this in pink. Basically something kind of like this. Right, like down 3, down 3, down 3, down 3, down 3. Everything's down 3. Is it? All right. So, their answer choices are all tables of values. I think what I would do is just play off the choices. So start with option A and then start testing coordinates. If something fails, just move on to the next option. Okay. So let's try this out. What if you plug in -6 for x? Well, let's start with f of x. Guys, if you plug in -6 for x, what is f of x? 0, right? Right. And then afterwards, if you shift that down 3, that gives you what y coordinate? -3. So this table has -9. So the answer cannot be A. Do you guys see that? We just eliminated A. Okay. So I know -6, -3 should be a coordinate on the for y. Oh, option B. Hey, that works so far. -6, -3. Option C, -6, -3. Option D, positive 3. So it's not A and it's not D. You guys see we just narrowed it down to either B or C. Right. How about -5? Guys, what if you plug in -5? What is f of x equal to? Also 0. And if you shift that down 3, you get -3. How about what if you plug in 4? F of x is 0. Therefore, y would be also -3. Okay. So, guys, what's the answer to 17? B. 17 is B. Guess that? We just checked all 3 of those. So everybody's good with 17 is B? Number 18. A landscaper uses a hose that puts 88x ounces of water in a bucket in 5 wide minutes. Here, I'm going to draw this out because I like pictures myself. So I can imagine this bucket's being filled up by this hose, spraying water, fill up the bucket. And it's putting in 88x ounces every 5y minutes. Okay. Now, that ratio should be constant regardless of how much time has passed. Right? This hose is just filling up this bucket, and we'll take this to always be true. Okay. That's a proportion. Which expression represents the number of ounces of water the hose puts in the bucket? 9y minutes at this rate. Let's solve this with proportions. So that proportion should be equal to, well, it should be a constant ratio, constant proportion. The hose is always fill up the bucket at that rate. I need 9y minutes. And see, we're solving for number of ounces. I'm going to use capital N for number as a number of ounces, and we're solving for that. You guys got that? We're solving for N. Does everybody see that where that proportion comes from? Okay, you guys got that proportion? Okay. And how do you solve this? What do? To both sides? Can I cross multiply the 9y? Okay. So that'd be like 88x ounces times 9y minutes, all divided by 5y minutes, is equal to n. Shouldn't that be the answer right there? Right? Now, granted, the answer choices, I don't see anything quite like that, but it looks like they probably multiply this out. Also, guys, what variable completely cancels? Yeah, the y. Doesn't matter what y is. What's 88 times 9? 88 times 9, that's 792. So 792. I'll have an x in the mix, and I got a 5 down here. That's all equal to the number of ounces. Okay, so I wonder if that's an answer choice. Maybe that's what they're looking for. That sure looks like option D is 18D. Yes, 18 is D. You guys got 18 is D? 18 is D. Number 19. Oh, this looks like sort of another system of equations. We're gonna write this bigger again for the camera. We got 4x minus 9y equals 9y plus 5. And hy equals 2 plus 4x. So there's my system right there. Okay. If the given system, in the given system of equations, h is a constant. If the system has no solution, what is the value of h? Okay. Now, guys, big picture. I see 3 unknowns. I don't know x, I don't know y, and I also don't know h. Now, by itself, guys, can you solve 3 unknowns with just 2 equations? By itself, normally? No, not normally. Okay. But they did give you a third piece of information, which is they're saying this has no solution. So what can you do with this? Okay. Now, here's where let's rewind way back to earlier today. You guys remember earlier in class today? There was this system of equations. We had to solve it. They said you could use substitution or elimination, or you could make a graph. And then we came up with this graph. We said the solution was wherever the 2 graphs cross. You guys remember that? Right. Well, if there's no solution, what does that tell you about the 2 lines? They must be what? Parallel. Aha. So I can use that to get to the answer. I'm going to rewrite these equations in slope-intercept, or I'll get it closer to slope-intercept form, like y equals mx plus b. So I add this 9y over here. That gives me 18y equals, I got a 4x, and I can subtract out this 5. So this is this. Does everybody see where I got this from? I just took the first equation and rearranged it. Okay. And I'll just take the second one and just copy paste it. Hy equals, well, sorry, I'll swap these two. So let's do 4x plus 2, just to get it a little bit closer to slope-intercept. Y equals mx plus b. You guys see that that's the exact same system of equations? You see that? Okay. Now I can get the answer really quickly from this, because you guys see these could have the same slope, right? Now that would only be true if they were parallel, right? Because parallel lines could have the same slope, and that would only be true if h is equal to what? H is equal to 18. That's the answer. The answer is D. Number 19 is D. Okay. Everybody good with 19 is D? You guys can see it from there? 19 is D. You guys ready for number 20? Number 20. 13 is p% of 25. What is p? Ooh, so real short expression there. This is one of many questions in this packet where the SAT wants to know, can you take a phrase and turn it into a math equation? So let's do that here. 13 is, guys, what does is mean mathematically? Equals. Aha. See, p%. What does percent mean in math? It means to divide by a what? 100. Yeah. For example, if you saw 50%, you say 50 over 100, that would represent a half. 50% is half, right? Okay. All right. Of 25. Guys, in math, the word of almost all the time means to do what? Of means to multiply. Okay, and then I got 25. Okay. I think there's some exceptions to that, but almost all the time, if you see of, you can almost safely all the time multiply with a couple of exceptions. Okay. So that is the expression in math form. Now, can you guys solve for p? Can you do it? Here, because what is 25 over 100? Yeah, 40. Okay. And what's 13 times 4? 52, like cards in a deck. Right? There's 13 cards, 4 suits. Did 52 cards altogether. Right. That's the answer. Number 20. You should have written 52. The answer is 52. Right, you guys got that? Right. Now, I want to do a little bit extra with this one. I want to show you guys a really cool math trick. You guys want to see a really cool math trick? You guys, everybody look up here? You guys, everybody look here. Take some notes. Let me go back to the original expression and write it out now that I know the answer. I'm going to say this. 13 is 52% of 25. Okay. Now, if somebody asks you, suppose somebody asks you this. Somebody walks up to you on the sidewalk and says, what is 52% of 25? And it's like, okay, well, that's not immediately intuitive. Here, guys, everybody look here. I'll show you guys a cool math trick. Okay. That's not immediately intuitive, but that is a little bit more than half, right? And 13 is a little bit more than half of 25. So I could believe that this could be true. Just kind of looking at it and saying, okay, that looks believable. Right? But watch this. 13 is, you're allowed to swap the percentage. So you can do this. 25% of 52. And that's a lot more intuitive to solve. You see, I just swapped what's on the percentage and what's the number. So 25% is not like a quarter. And a quarter of 52 is definitely 13. Because that's like cards in a deck again, right? Right. So yeah, if you're ever asked a percentage question and you don't know the answer right away, try swapping the numbers and see if it's more intuitive, because you could solve it that way too. 21. Ooh, some square root is equal to a different square root. Try this out. Got square root of x minus 2, being squared, is equal to square root of 3x plus 34. The question is, what's the smallest solution to the equation? So that implies that maybe there's more than one solution. And so let's go through this. Hopefully we get more than one solution. So I would indicate we're on the right track. Is what's the very first algebra step? Do what to both sides? Square both sides. So that's x minus 2 being squared is equal to, and 3x plus 34. Okay, the root just went away. Guys, what's the next step? Can I expand this out like this? X minus 2, x minus 2. Is that okay? You guys remember FOIL, FOIL? Stands for first, outside, inside, last. You guys remember first, outside, inside, last? Let's do that. Okay. So let's get to look like this. X squared minus 2x minus 2x is minus 4x altogether. Here's what is negative 2 times negative 2? Plus 4. All right, and that's your 3x plus 34 I still have over here. Is that okay so far? Is everybody good so far? Okay. All right. How should I, what's next? Yeah, combine like terms, right? Now, big picture here. I do have an x squared. There's also an x, and there's also constants floating around. That's gonna kind of funnel this toward what word am I thinking of? Starts with a Q. Quadratic. Quadratic. Okay. And a good way to solve a quadratic is you can get everything set equal to what? 0. So here, let's do that. Combine like terms like you're saying. I can subtract the 3x over. That gives me minus 7x. And then also subtract over 34. That gives me minus 30. Now that's set equal to 0. Okay? Okay. Now, at this point, show of hands. How many of you guys have memorized the quadratic formula? Who knows the quadratic formula?
Yeah.
A couple of guys? I'm going to recommend you know that for next week. That could definitely be helpful. Now, the way SAT phrases these questions, you can usually just factor. So let's go ahead and do the factor method, but the quadratic is going to show up later today, so just wanted to do. So I need two numbers that add up to -7 and multiply to -30. What are those two numbers?
And then -3.
Aha! Yeah, -10, 3. There you go. Right. And if you aren't sure if you did it right, then you could use the FOIL process to work backwards and see if it confirms it. So x times x is x squared. Got 3x minus 10x is -7x. And I got -10 times 3 is 30. Boom, boom. Okay, so that works. That works. Right. Now that I have two different things multiplied together, multiplies to 0. Isn't it true if either one is 0, the whole thing is 0? So from this part, you can get x is equal to what? 10. And from this part, you can get x is equal to what? -3. So, yep, there are two solutions. We were looking for two solutions, so that's good. Okay. Now, I'll say this too. Guys, when you solve something like this, go back to the original statement. The fact that there were square roots in the original statement, make sure that you aren't taking the square root of a what? You're not allowed to take the square root of a negative number. Aha. Okay. Now, if you run the numbers, they're both okay. This one on the left is definitely okay because it's being squared. You can't get a negative under that. Right. This one on the right, whether I plug in 10 or -3, both times I get square root of a positive. So we're okay. So back to the packet then. What answer are they looking for on number 21? So the correct answer is what? -3. Because they were looking for the smaller of the two values. So -3. The answer is -3. Everybody's got number 21. The answer is -3. Number 22. Function f is defined by, let's get this down here. F of x is, hey, it's another one of these. X plus 6, x plus 5, x plus 1, all multiplied together. Here, I'll throw down g of x while we're at it, which is f of x minus 1. All right, so we'll get back to that. But let's get f of x on the board first. Did I do that right? Yeah, you did that right. X-axis, y-axis. Okay. Guys, go ahead and graph f of x. Graph f of x. Make sure everybody can definitely do this one, because you guys just saw a really similar one a few minutes ago. Can everybody graph f of x? So, did you guys come up with the intercepts of point? At -6, at -5, and at -1, there would be intercepts. You guys got those three for x intercepts? Okay. How about for y intercept? Oh, how do you find the y intercept again? Yeah, you plug in 0 for x, and if you multiply that together, what does that give you? 30. Aha. So here's your y intercept. It looks like my graph, not exactly to scale, but you guys get the idea. You guys think the graph is basically going to look like that, some version of that? Okay, so that right there is f of x. Okay, that's f of x. Okay. Now g of x, maybe I should have done a different color for g of x. Let's do g of x in pink ink. G of x is f of x shifted which way, how much? To the right. Aha! Shifted to the right one. Okay. So take this whole graph, just shift it to the right one. So here's -4 here. So should that go through here, and then through the origin? And that right there is your g of x. Right? Is that true? Okay, g of x. Okay. Let's test. Let's see if this is actually true. I'm making the claim that g of x goes through the origin. So if you plug in 0 for g of x, you also get 0. Right? Let's see how that translates. Because I know here I want to show you guys that this for sure is shifting to the right. If you ever forget why is that true? Right. So if I plug in 0 for x, that means that would be f of -1. And f of -1 is what again? 0. Aha! Yep. And g of 0 is also 0. Yeah, so that works. That works. Okay. Now, the packet. They're saying the zeros, the x-intercepts for g of x are a0, b0, and c0. Ah, isn't that like -5, -4, and then this point here would be well, like well, 0 for 0, 0. Right, those are the x coordinates. So a, b, and c are -5, -4, and 0. And they want you to add those up. What is a plus b plus c? So guys, what is a plus b plus c? What does that add up to? -9. The answer is B. 22 is B. You guys got 22 is B? 22 is B. Number 23. For x's only positive values, the function f is defined as follows. F of x is 201% of x. Let's do what we did a few minutes ago. Let's turn that into an equation. F of x equals, so I'll say equals, 201%. Here, I'll go ahead and spell it out first. 201% of x. So f of x is, guys, what is 201% written as a decimal? Yeah, 2.01. Right. And what did I say a few minutes ago of almost all the time means in math? It means to do what? Multiply. Yeah. Right. Hey, could you graph that? Let's all graph that. X-axis, y-axis. Make sure you guys know how to read that. We'll walk around, see who knows how to graph that. Who knows how to make that graph? Kate got it. Alexander got it. Elise got it. Zach got it. Am I missing anything? Oh, Isabel got it. All right. All right. I think a bunch of you guys are getting this. A bunch of guys just drew this right here. Zip. Okay. You guys, here, let's get some coordinates. If you plug in 0 for x, 2.01 times 0 is 0, so it goes through the origin. And this has a slope of what? 2.01. Okay. So if x is 1, y is 2.01. If x is 2, y is 4.02. If x is 3, y is 6.03, I think. Okay. So whatever x is, y is a little bit more than double that. Right? So wouldn't that be a linear? Oh, whoops. Actually, I have to amend my graph a little bit. Because they said x is strictly greater than 0. So I need to get rid of all this negative stuff and also open up a hole at the origin. Okay, actually, that would be more strictly what they have. Okay, but that doesn't matter anyway for their answer choices because they're saying, is it increasing or decreasing, and is it exponential or linear? And you guys say it's which one of these options? D, increasing linear. You guys see that? The more x is, the more y is. That's increasing. Like if left to right, you're walking uphill, and it's linear. That's it. All right, you guys go down 23. You guys ready for 24? At 24, I got, okay, so 24, got f of x is 4x squared plus 64x plus 262. Okay, and then, well, g of x is f of, and then x plus 5. What value of x is g of x reach its minimum? So let's start with f of x, and then we'll figure out what from there. And so how can I graph f of x? Right. Now, there's different ways to approach the graph. You could try to factor it, but because the fact that they're asking about a minimum, I should say this, because what basic shape is this graph? It's basically what shape? A parabola. So it's a parabola. When you're trying to find the minimum of a parabola, is that also called the vertex? Right. And how do you find the vertex of a parabola from an equation like this? Do you guys know how to do that? Right. Let's show you guys a trick here. So do you guys remember if you have y equal, equals ax squared plus bx plus c, which would be a parabola like we have. Okay. If you set that equal to 0, then you could solve for x by the quadratic equation. Right. Did I tell you guys earlier today the quadratic equation was going to come up? Here it is. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a.
There's no.
Okay. You guys hear that? Okay. Now, if you know how to read the music of this equation, see, this will tell you the 2x intercepts, where hence it would zero out. Okay. But there's more to it, because do you guys see that square root right there? Again, you're not allowed to take the square root of a what? Negative number. Is it possible b squared minus 4ac could come out negative? Okay, I haven't actually tried this one yet. Let's see if it does. B squared, here's your b. So I square that. Minus 4 times a times c. Minus 4ac. Yeah. Okay, guys. I just ran b squared minus 4ac for this equation, and I got a negative number. What does that mean? That means this parabola has no what? Has no x-intercepts, has no zeros. Okay. So the whole parabola, which has a y-intercept of 262, I know this is 262 up here. The whole parabola is above the x-axis. Okay? Right, you guys see that? Right. Now, what is this x value right here? Because I want to know the x of this vertex. You guys get that? Okay. And that you can get from another part of this formula. You guys see, here, I'll circle it in pinking. Do you guys see this part right here? Guys, everybody look real close at this, because if you don't know how to do this, here's a really cool trick. You guys see this negative b over 2a bit I just circled? Right? That tells you the x location of the vertex, because then when you do plus or minus the square root, on the graph, you're effectively just branching out from that vertex point. Like plus or minus the square root, so you're just doing left or right of that vertex. Is that? So negative b over 2a tells you where the vertex is. True? Right? So let's do that for this right here. Negative b over 2a. So x vertex is at negative b over 2a, which is negative 64 over 2 times 4. Ooh, guess what is that? What is negative 64 divided by 8? Huh? Negative 8. So what is this value right here? Negative 8. Yes, negative 8. Okay. And if you plug negative 8 into this equation, you can get the y value, which would have to be positive. Actually, let me prove to you guys that this is positive. I haven't done this yet, but we're about to. I have to get a positive number because I'm making the case that the parabola has to be above the x-axis. Okay. So 4 times negative 8 being squared plus 64 times negative 8 plus 262. Yep, it's 6. Okay, which doesn't matter so much to this question, but there it is if you wanted it. Okay? That's good? Okay. All right, every good so far. Every good so far. All right, so what are they at? Ask here. If g of x, you guys remember, is f of x plus 5? So guys, g of x is the original graph f of x shifted which way, how much? Left 5. 1, 2, 3, 4, 5. Right, here, maybe I'll do g of x and pinking. Could that be g of x right there? G of x. Here's your f of x. Right. Therefore, guys, what's this vertex right here? Aha. Guess it has to be negative 13. Guess yet? Right, okay. That's the answer they're looking for. So number 24 is A. You guys got 24 is A? 24 is A. You guys got that? Okay. We're going to do one more today. Number 25. Here's the last one today. Number 25. 1 gallon of stain will cover 170 square feet of a surface. A yard has a fence with area W square feet. Which equation could represent the total amount of stain and gallons needed to stain the fence twice? Ooh, there's definitely a little curveball right at the end because we have to stain it, but then we have to go back and stain again, which is like double the amount of stain. So 25, and there might be different ways you could approach this, but this sure does remind me of a proportion. Here, guys, I got some fence. I need to go stain this whole fence. Okay. I know that 1 gallon covers 170 square feet. Okay. Now that proportion should be true all the way around the fence. I got this whole fence going. Guys, yeah. Okay. So I'll say equals. I'm going to set it up for proportion. I'll solve it that way with our proportion. All right. So equal to what? Okay. I want to solve for some number of gallons, S, to cover W square feet, because it's W square feet, however big that is. So that goes in the place of the area. You guys good so far? Okay. Now, guys, there's one more detail. Okay. If I solve it at face value, I can only stain the fence once. But what they want for S, we need to buy like double the amount of stain. So actually, my equation doesn't exactly cut it. This only represents half of what you actually want. So I'm going to throw on a 1/2 right here. Okay, because there might be a better way to explain that, but or maybe instead of S, maybe you could call it like V for volumes, or I don't know, right? Or N for number. And then you can go back at the end and you have to double it. Like whatever you get here, if I didn't have the half, at the end of the day, you'd have to go back and double it, right? Or I could throw in a 1/2 factor and solve it that way. Okay. Right, so however you think of it, I need to multiply over the 2 and also multiply over the W. So that's 2W over 170 is S. The amount of stain to go back and paint the fence twice, or I should say stain the fence twice. Okay. Now I can reduce this. Guys, what is 170 divided by 2? 85. Okay. I think that's the answer they're looking for right there. Say, is that D? Make sure the answer is D. Yep, 25 is D. Okay. All right, that is our pause point today.